another section on conics. Remember, these were the 4 conic sections. Today we're going to do something a bit across them, which is for circles and parabolas, and ultimately it'll work for ellipses and hyperbolas as well. But for circles and parabolas today, we're going to do something called completing the square. Okay, so what is completing the square? The idea is that you start with a parabola, for example, of the form ax squared plus bx plus c, and you convert it into the form that we're used to seeing, which is y equals a x minus h squared plus k. So the problem with this, which we've been doing up to this point, is that typically equations don't look like this. They look like this. I'll give you an example. The equation for the distance of an object thrown in a gravitational field is x naught plus v naught t plus 1/2 gt squared, where x is the position, or the distance you're throwing it. x0 is your initial position, where you're starting when you're throwing it. v0 is your initial velocity, t is time, g is gravity. This is a quadratic, a parabola, and you can tell that because it says a t squared in it. However, it also has a t in it. So this is in this form right here, ax squared plus bx plus c, except that x is t. And actually I can write it in sort of look more like that if I do this. Just reverse the terms. Now you can see there's something t squared plus something t plus a constant, this up here. So this is how most equations actually look, most physics equations, for example. And you want them to look like this so that you can tell where the vertex is, for example, in a gravitational field. When you throw an object, where is its peak? And that'll be at hk. Okay, so today we're going to talk about how you convert this form, which is called standard form, into this form, which is called vertex form. We will then do the same thing for a circle. Okay, so I'm going to start with an example and just show how to do this with some steps. I'm going to start with the equation y equals x squared plus 6x plus 3. Okay, and again, the problem with this is I can't look at this and tell what the vertex is. This is called standard form. I have an x term as well as an x squared term, and therefore it's not in the form that I can just pick the vertex out. So I'm going to convert this into a form which is y equals, and we're done, a x minus h squared plus k. So I can tell the vertex, and also I can tell a, although I can tell a right from there, on the one on the top actually. Okay, so what I'm going to do is I'm going to convert this part here, which is x squared plus 6x, to something which is more like x minus h squared. And the way you do that is a multi-step process. The first is you take the middle part, the number in front of the x, take number in front of x, and divide by 2. Now you don't actually then put it back into the equation, it's just to give you a number, so I'm going to do that here. 6 is my number in front of the x, divide by 2, and that gives me 3. Okay, that is going to be one of the terms of the vertex. So put this number inside the parenthesis with x plus 3 in there. X plus this 3 goes in there, and square it. That is going to be part of the equation. Then, however, what you do next is you take that same number and you square it. Also here, take same number, square it, and subtract from step 2. Now you have x plus 3 squared minus 3 squared. Okay, this right here, and I'll show that in a moment, is the equivalent of x squared plus 6x. So I can just replace it. So replace answer in 3 with our answer in 3 into original equation. Okay. So that's what I did here. Actually, that should be here, really. This is just squaring it. There we go. And then we have to, no, that's fine, actually. And then we have to add, this is what I replaced up there. And then I add the 3 that already existed there. And then finally, simplify. So I simplify this down and I get y equals, should be y equals, x plus 3 squared minus 9 plus 3, or minus 6. And there's my final answer. Before I go and do another example, I'm going to actually show that that's the same as that. So what I do is I expand x plus 3 squared, which is x plus 3 times x plus 3. And then I'm going to expand that, FOIL that from algebra. X squared plus 3x plus 3x is plus 6x plus 9 minus 6, which is x squared plus 6x plus 3, or exactly what I had originally. So all this is here is this right here, what I came up with is an identical form to this, identical equation to it. It's just in a slightly different form. Again, let me go through the process. So what you do is you take the number in front of the x, divide by 2, and do 2 things with that. Put the 3 and make it x plus 3, the whole thing squared. And then you also square that 3 and subtract it. And what you're doing basically is this last term is 3 squared, and you subtract 3 squared. When you expand it, that gives you the equivalent x squared plus 6x. Then you replace that x plus 3 squared minus 3 squared in your original equation up there. And simplify down, and now I've got it in vertex form. Now, why is the benefit of that? I now know that the vertex, for example, HK, just by looking at it, is -3, -6, which allows me to graph it. A didn't change, it's still 1. It's the term in front of the x squared. So now I could graph this parabola, get the focus, get the vertex, etc. Okay, I'm going to do another one. I'll walk through the process again, do several of these just until you guys get it down. So here's another one, y equals x squared minus 4x plus 6. Again, that is in standard form, not vertex form. So again, first step, take that -4 and divide by 2. That gives you -2. Second step, write that in x minus 2 squared. Third step, take that same -2, square it to get 4, and subtract it from that term there. So this becomes now x minus 2 squared minus 4. And when you expand this out, this will give you plus 4 there, and then you subtract 4, so it'll work. Substitute that back in there. Y equals x minus 2 squared minus 4. I'm substituting this for this. And then I still have the plus 6 on the outside. That hasn't changed. So simplify down, and I get y equals x minus 2 squared plus 2. And there we go. There's my vertex form. And again, I can take the vertex from that. It is 2, 2. And a is again just 1. Okay, now I'll have you try one. There we go. Y equals x squared plus 8x plus 10. That's in standard form. I want you to get it down to vertex form and tell me what the vertex is. Okay, pause the video. Okay, if you're back, first take that 8 divided by 2, and that gives you 4. Do 2 things with that 4. One is, let's put it there, x plus 4 squared. Then square that number, which is 4 squared, is 16, and subtract it from that. Take that, substitute for right here. That's your fourth step. There's the substitution. Simplify down, and you get x plus 4 squared minus 6. And the vertex is -4, -6. And a is 1 again. Okay, we'll try one more. equals x squared minus 10x plus 22. Again, I'll put the steps down here. Pause the video, do it yourself. Okay, if you're back, all you do is you take that negative 10 again, divide by 2, that gives you negative 5. Write it as x minus 5 squared. Take that negative 5 as well and square it, which is 25, and subtract it from there. X minus 5 squared minus 25. Substitute that in for the x squared minus 10x, which is what it's equal to. And simplify down. And my vertex, therefore, is 5, negative 3, with an a of 1 again. Okay, and you could take this now and graph it just like we were doing when we were doing parabolas. But watch the parabola video for that. Okay, now we're going to do the same thing with circles. So again, more commonly in equations, this is parabola complete square, now we'll do circle. You have two forms for a circle. The most common one is called standard form, which is x squared plus y squared plus cx plus dy plus e. And you want to write that into, this is called standard form, sorry. Standard form. You want to write it in center radius form, which is what we've been dealing with, which is x minus h squared plus y minus k squared equals r squared. Okay, so we're going to do this by, again, completing the square. Again, you'll know it's in the wrong form because we'll have an x term and a y term, and this does not. So I'm going to give an example. Let's start with x squared plus y squared minus 8x plus, now it's a minus 6y plus 9 equals 0. So that's standard form. So a bunch of stuff equals 0. It's got an x term, it's got a y term, so I don't know what the center is. I don't know what the radius is. Okay, so here's the steps. First step is the group the x terms and group the y terms. So in other words, put x squared with the 8x, minus 8x, put y squared with the minus y, and we're going to put the 9. We could leave the 9 there, but I'm actually going to put it on the other side and make it negative 9. Okay, second step, complete the square with this, then complete the square with this, and then we'll simplify down. So you do the same thing you did before when you're doing parabolas. Take the negative 8, divide by 2, which gives you x minus 4 squared. Take that same negative 4, square it, and subtract it. This is exactly what we did with the parabola. X squared minus x is the equivalent of x minus 4 squared minus 16. You can see that if you actually expanded it out. Do the same thing over here. Y, take that negative 6 divided by 2, square that, and subtract it. You're always going to be subtracting these, by the way, in both parabolas and circles. And that equals negative 9. We're close now to this form. Now what we finally do is, so this is complete square on both. It doesn't even look like square at all. Okay, and now I'm going to put all these numbers on the other side. So I'm going to add 16 and add 9, and over here I'm going to add 16 and add 9. That'll give me x minus 4 squared plus y minus 3 squared equals, those cancel, 16. Okay, so now I know my center is 4, 3, and my radius is radical 16, or 4. So this step is put numbers on other side. Okay, so let me go through this again, and then we'll do some more examples. So if you've got a circle in standard form, which means it's a bunch of stuff equal to 0, and it's got x and y, or x or y, it doesn't have to have both. What you do is you group the x terms and group the y terms together. Just rearrange the equation slightly. Put the number on the other side. You'll see why down here why I wanted to do that. Then complete the square on both the x terms and the y terms, just like we did for the parabola. Put the numbers on the other side, and it will be in center radius form. Okay, so I'm going to give you a couple more examples for this to work through. So we're going to start with the equation 0 equals x squared plus y squared plus 4x minus 10y plus 4 equals 0. Okay, whoops, it was 0 twice. Okay, so it's 3 steps again. I'll do one myself, and then I'll have you pause and do one. Again, group the x's first. X squared plus 4x plus y squared minus 10y. Let me put the 4 on the other side. Complete the square on each. Take the 4 divided by 2, which is 2. And make that x plus 2 squared. And then subtract 2 squared, which is 4. Do the same thing with the y. Negative 10 divided by 2 is negative 5. So this becomes y minus 5 squared minus negative 5 squared, which is 25. And that equals negative 4. Okay, now put the numbers on the other side, and I get x plus 2 squared. I'm going to add 4 there, and add 25 there. So here I have to add 25 and add 4. The 4's cancel, and I just get 25. And I'm done. My center is negative 2, 5, and the radius is radical 25, which is 5. And you can graph that just like we did before. All right. How are you guys doing then? It's going to be in slightly different form, but not much. You should be able to handle it. X squared plus y squared plus 6x plus 2y equals negative 1. Okay, pause the video and try that one. Get it down to center radius form. All right, if you're back, I'm going to rearrange first. X squared plus 6x plus y squared plus 2y equals negative 1. The negative 1's already on the other side, so that actually was handy. Then complete the square. 6 divided by 2 is 3. So this becomes x plus 3 squared minus 3 squared. And this one is 2 divided by 1 is, 2 divided by 2 is 1. So this becomes y plus 1 squared. And then subtract 1 squared. That equals negative 1. Add a 9 there, add 1 there, add 1 and add 9. And you get x plus 3 squared plus y plus 1 squared equals 9. So my center is negative 3, negative 1, and my radius is 3. Hopefully you got that. Okay, a couple in slightly different form again. Here's another one. X squared minus 12x plus y squared equals 0. Okay, again, this is slightly different because there's no y term. That's fine. You just have to complete the square on the x part. So give that a try. Pause the video. Okay, if you're back. So this becomes, first group them. They're already really grouped, so that step is kind of unnecessary in this case. Take that the middle determinant of the x, divide by 2. That gives you negative 6. So that comes x minus 6 squared minus negative 6 squared, which is 36. And plus y squared, there's nothing to complete there. It's already completed square, equals 0. Last step, add the 36. And we are done. So my center is 6, 0, and my radius is 6. Okay, that's it. So let me just summarize and give the homework. We are completing the square for parabolas and circles, and the whole point of that is to generate something for a parabola. The idea is you go from an equation that looks like y equals ax squared plus bx plus c to an equation that looks like ax minus h squared plus k, so that you can get the vertex out. For a circle, you're going from an equation which looks like x squared plus y squared plus cx plus dy plus e to an equation or equals 0 to an equation which is x minus h squared plus y minus k squared equals r squared. And again, the whole point of this is more commonly how they are generated in physics, and this is what actually gives you the useful information. So I'm not going to go through the process again, as that was the whole lesson, but here's the homework for geometry and for college algebra. For geometry, the homework is a worksheet on completing the square. I don't think there are any book problems again. And for college algebra, just complete the homework. You should be doing this with the other videos you've watched. Complete homework 29. Okay, that is all. Until next time, thanks.